to draw the Lewis structure. Let's consider the first example, which is OF2 molecule. In OF2 molecules consists of two types of atom, which is oxygen atom and the fluorine atom. Oxygen atom is from group 16 with 6 valence electrons, and fluorine atom is from group 17 with 7 valence electrons. So the first step to draw the Lewis structure, that is, we need to count the total number of the valence electron for each atom in the molecule. For oxygen atom, we have only one atom with 6 valence electrons. So that gives us 6 valence electrons. While the fluorine in the molecule consists of 2 fluorine atoms, each one with 7 valence electrons. Therefore, we have 14 valence electrons. That gives us a total number of valence electrons with 20 valence electrons. So now, the second step is to draw the skeletal structure for the atoms in the molecules. Since the oxygen is less electronegative than the fluorine, therefore, oxygen will be central atom and the fluorine will be the terminal atom. So, to draw the skeletal, so we locate the atoms in the structure. O as a central, F to the terminal. So now, the next step is to draw the single bond to show the bonding between the central atom and the terminal atom. So, oxygen atom bonded to 2 fluorine atoms, so we have 2 single bonds. In 2 single bonds, we have used 4 electrons. So, minus 4 electrons from the remaining electrons, from the total number of valence electrons, so that gives 16 remaining electrons. So, the next step is to locate all the remaining electrons as lone pairs to the terminal atom to make it the terminal atom become octet. So since the fluorine have one single bond with 2 electrons, therefore fluorine needs 6 more electrons to be octet. So place the remaining electrons to the fluorine atom. So each of the fluorine atom has 3 lone pairs with 6 valence electron each of the fluorine. So now fluorine have achieved octet with 8 electrons. So for 2 fluorine atom, we have used 12 valence electron for the lone pairs. So that shows we still have remaining electrons with 4 valence electrons. So, these 4 remaining electrons will distribute to the central atom as a lone pairs. So now, this lone pairs has used 4 valence electrons, so it shows no more electrons left. So now we have already distributed all the valence electrons towards the 3 atoms involved in the molecules. So the next step is to check whether the atoms is satisfied the octet rule. Look at the fluorine atom. Fluorine have 1 bonding pair and 3 lone pairs. So that shows fluorine atom was surrounded by 8 electrons. So this shows fluorine achieved octet configurations. Another fluorine atom have the same number of bonding pair and lone pairs. So this fluorine atom also achieved the octet configuration. So it was satisfied the octet rule. While the oxygen has 2 bonding pairs and 2 lone pairs. So it was shown it is surrounded by 8 electrons. So oxygen also satisfied the octet rule. So now all the atoms has satisfied the octet rule. So this structure is acceptable as a stable Lewis structure. The second example is C2H4 molecule. In this molecule consists of carbon atom and the hydrogen atom. Carbon is from group 14 with 4 valence electron and hydrogen is from group 1 with 1 valence electrons. So the first step is to count the total number of the valence electron of each atom involved in the molecule. So carbon, we have 2 atoms with 4 valence electron each. So that gives us the total number of valence electron equals to 8. Hydrogen, we have 4 atoms involved with 1 valence electrons. So we have 4 total valence electrons. So that gives us the total number of the valence electron in the molecule equals to 12 valence electrons. So the next step is to draw the skeletal structure. So the skeletal structure, we have to decide which atom will be the central atom and the terminal atom. So the more electropositive atom will be the central atom, while the more electronegative atom will be the terminal atom. So in this case, hydrogen is more electropositive than the carbon atom. But the hydrogen cannot be the central atom because hydrogen is only from a duplet configuration, which is they only accept 2 valence electrons. So it is impossible to locate the hydrogen as a central atom. So we have to put the carbon as a central atom. So since we have 2 atoms of carbon, so that means we have 2 central atoms. So now let's locate each of the atom as a terminal and a central atom. Carbon as a central atom, so since we have 2 carbon, so we have 2 central atoms. And it was surrounded by 4 hydrogen atoms, whereas each of the carbon was surrounded with 2 hydrogen atoms. So next is to show the single bond between the carbon and the hydrogen, as well as between the 2 carbon. The 5 single bond between the carbon and hydrogen and carbon atom, we have used up to 10 electrons. So bonding pairs, electrons, we have used up to 10 valence electrons. But still we have remaining electrons with 2 valence electrons. The 2 valence electron we can locate to the terminal atom to make it octet. But since in the molecule the terminal atom involves the hydrogen atom, which is only can obtain duplet configurations, so with 1 single bond the hydrogen is already satisfied the octet rule. So the 2 remaining electrons we can locate to the central atom as a lone pair. So no more electrons to be distributed. So the next step is to check whether the molecule is satisfied the octet rule. First, check the terminal atom whether they are achieved duplet or octet. So hydrogen with a single bond, they are already duplet. Then check the central atom. The first carbon, they have 3 bonding pairs that involve 6 electrons and 1 lone pair that involve 2 electrons. So that gives a total number of the valence electron that surrounded the first carbon atom is 8 electrons. So this satisfies the octet rule. For the second carbon atom, they have 3 bonding pairs that involve 6 valence electrons. So that shows the second carbon is not satisfied the octet rule. To make it satisfy the octet rule, we can rearrange the lone pair between the 2 carbon to make a double bond. So it obtains carbon-carbon double bond between the 2 central atoms. So now both of the carbon at the central has achieved octet configuration, which is satisfied the octet rule. So now we can accept the Lewis structure as the most stable structure. Now, let's consider the next example, which is NO2 plus ion. So, in NO2 plus ion consists of nitrogen atom and oxygen atom. So, the nitrogen atom is from group 15 and oxygen atom from group 16 with 6 valence electrons. So, the first step is to count the total number of valence electrons for each atom in the molecule. So, nitrogen, 1 atom times 5 valence electron. And the oxygen, 2 atom times 6 valence electron. Since we have positive charge here, so we have to subtract 1 electron. So that gives the total number of the valence electrons with 16 valence electrons. The next step is to draw the skeletal structure for the molecules. So since the nitrogen atom is less electronegative than the oxygen, so the nitrogen will be the central atom, and then the oxygen will be the terminal atom. So locate the atoms in the molecule for the central and the terminal. So nitrogen at the central and the oxygen at the terminal. So then show the bonding pair between the nitrogen and the oxygen. So we have 2 bonding pair involved, so that means we have used 4 valence electrons. Using 4 valence electrons, so that gives remaining electrons with 12 valence electrons. So this remaining electron we need to distribute to the terminal atom to make it octet with 8 electrons. So now oxygen already have 2 electrons from the bonding pair, so it requires another 6 more electrons to be octet. So this oxygen atom also need 6 more electrons. So from the lone pairs of the oxygen atom, we have used 12 electrons. So lone pairs using 12 valence electrons, so we have no more valence electron left. So the next step is we have to consider whether this molecule has satisfied the octet rule. So for the oxygen atom with 1 bonding pair and 3 lone pairs, it shows that oxygen has 8 valence electron that satisfy the octet rule, while another oxygen atom also satisfied the octet rule. But for the nitrogen atom, they only have 2 bonding pairs with 4 electrons involved. So that shows the nitrogen, it is not satisfied the octet rule. It needs 4 more electrons to be octet. So we have to transfer the lone pairs from the oxygen atom to make a double bond. So sharing electron between the oxygen and the nitrogen will increase the number of valence electrons that surrounded the nitrogen atom in order to achieve octet configuration for the nitrogen. So the first lone pair is from the first oxygen atom. And then we need more electrons from the second oxygen to give more electrons to the nitrogen. So now it will obtain double bond between the nitrogen and the oxygen. The lone pair of the oxygen atom remains 2 lone pairs, which is one of the lone pair has been used up to form a double bond with the nitrogen atom. The next oxygen atom also share their lone pair to the nitrogen atom and left another 2 lone pair. So now we have this Lewis structure. So let's check whether this molecule has satisfied the octet rule. Oxygen atom, after they shared the lone pair to the nitrogen, so it has 2 bonding pair and 2 lone pair. So that gives 8 electrons that surrounded the oxygen atom which is satisfy the octet rule. While another oxygen atom also have 2 lone pairs and 2 bonding pairs, so that give 8 electrons that surrounded the oxygen atom that satisfy the octet rule. While the nitrogen atom, when they accept the sharing electron from the oxygen, so they form 2 double bonds, okay, between the oxygen and the second oxygen atom. So it also surrounded by 8 electrons. So nitrogen is now achieve octet configuration with 8 electrons. So it is satisfied the octet rule. So therefore this structure we can accept as a stable Lewis structure for NO2+. But remember, that is, since we have the charge for the molecules, so we have to put square bracket and +1 charge. Now, let's consider the fourth example, which is BF4 1- ion. In this molecule of ion consists of boron atom and the fluorine atom. So boron is from group 13 with 3 valence electron and fluorine from group 17 with 7 valence electrons. So the first step to draw the Lewis structure is to count the total number of the valence electron in a molecule. So boron with 1 atom and the 3 valence electron each. So it gives us 3 total number of valence electron. While the fluorine atom involve 4 atoms with 7 valence electron each. So that gives us 28 valence electrons. So since this is an ion with -1 charge, so we have to add 1 electron. So that gives us the total number of the valence electron with 32 electrons. So the next step is to draw the skeletal structure. So in these molecules, so boron is less electronegative, so it will be the central atom, while the fluorine will be the terminal atom. So locate in the skeletal boron as a central and the 4 fluorine atom as the terminal atom. So the next step is to draw the single bond to show the bonding between the central atom and the terminal atom. So this 4 single bond between the boron and the fluorine has used up to 8 electrons. So bonding pairs, we have used up to 8 valence electrons, and that gives us remaining electron with 24 valence electrons. The 24 remaining electron we have to distribute to the terminal atom to make it octet. So since the terminal atom of fluorine now has only 1 bonding pairs that involve 2 electrons, so to achieve octet configuration, each of the fluorine atom require 6 more electrons to be octet. So using the 24 remaining valence electrons, we give 6 electrons to each of the fluorine atoms, so therefore it can achieve octet configurations. So distributing the lone pairs to the fluorine atom, we have used up to 24 electrons. So now we have no more electrons to be distributed. So the next step is we have to check whether this molecule is satisfied the octet rule. So first, check the terminal atom. Fluorine atom with 3 lone pairs that involve 6 valence electron and 1 bonding pair which is involve 2 electrons. So the total number of the valence electron that surrounded the fluorine atom is 8 electrons. So all the fluorine atom is similar in this molecule of ions. So now check the central atom. Boron have 4 bonding pairs which is involve 8 electrons. So that shows boron has achieved octet configuration. So that means these molecules is satisfied the octet rule. So we can accept this structure as the stable Lewis structure. But remember, since this molecule is the ion, so we have to show a square bracket with -1 charge ion.